Hey, what's up everyone? So I feel like all the time I'm just scrolling around the internet, doing my thing, and I stumble into these time series animations, these like populations over time or company size over time animations that I don't know what it is about them, but I just like can't peel my eyes away. I'm so intrigued and fascinated by these simple moving lines across the screen. And it got me thinking, could we replicate this type of animated graph in Python? And it turns out we can, and it's pretty easy to with just basically Matplotlib. So in this video, we will see how we can make bar chart race animations with Python and Matplotlib. And then probably in a follow-up video, we will see how we can do line graph animations. So if you wanted to visualize stock prices over time or something similar, you could also do that with Python and Matplotlib. Should be a lot of fun. Let's get into it. So the first task for a project like this is to find a data set that has a time dimension. So we'll be doing country populations over time. And a great place you can get data on that is from the UN World Population Prospects data set. And so there's a link in the description to this data set, but a simpler way to get it is that there's also a link in the description to a GitHub repo that has the data set already in it and data/UN country data. So you can clone this repo and get this locally, or you could just individually download this file locally if you wanted to. Once you have the code locally, I recommend opening up VS Code or your code editor of choice. So the first step in creating animations will be to do some simple data processing. So if we look at what our data set looks like, and in VS Code, there's this nice little way to preview your CSV files. So I'm going to click the preview button. And we see we have our data set of country data. A lot of blankness here at the top. But if I scroll down, we see some actual data. So this is for Qatar, it looks like. The ISO 3 code will be helpful to have. The location will be helpful to have. And let's just check to see how this data is laid out and the time component. And then probably this population columns, total population, January and July will also be helpful. So let's go ahead and take those pieces of data and maybe save it as a populations cleaned CSV. So I'm going to create a new notebook. I'll just call it cleaning.ipython notebook. I will open up our data set, import pandas as PD, df equals pd.read CSV data/UN country data.csv df.head. Just make sure I have it loaded in. Looks good. So we want to make sure that let's just say the ISO 3 code is NA or is not NAN. That might be an easy way to start filtering things. So we'll call this countries. And we can just do df.iso 3 code not null. How about that? And this should be a little bit simpler of a data set. Okay. And now let's just grab columns that we want. So columns equals country. So we want ISO 3 code. We want the location. We want, if we scroll through this a bit, I guess we can't see all the columns, so maybe I print the columns quick. Okay, we have the columns now, so what columns do we want? ISO 3 code, location, time, and I want T population, 1 Jan, and how about T population, 1 July, and now clean df will say is equal to country columns. Now let's look at this data frame. Okay, much easier to work with. Now, basically, we could even rename this, but to start out, this is probably a good starting point. So we could maybe just save this as CSV like cleaned data.csv. I like to do index equals false, and I have this data folder, so we'll save it in our data folder. We see we now have clean data. Okay, now that we have this clean data, step 2 in our task will be to create a simple just plot of this data. And so we won't worry about animating yet. We'll just create a plot. But I'm going to call this file animation.py. And in it, we're going to want to load that data and just plot it. So we could do something like, and actually, if you really wanted to, you could stay in this Python notebook, maybe just to get some basics down before converting it into a script. Either option works. But I'm going to do it in the script here. So same thing, I'm going to import pandas as PD. We're also going to import matplotlib.pyplot as PLT. Good standard first steps. And really, okay, we want to load the data. So pop data, how about, equals pd.read CSV. We now have saved that as data/cleaned data.csv. This is just this. Okay. And then if we look at what is in that data set, right? Let's just plot the top 10 countries at a certain point in time, because animating it will have to like, the next step will be basically to iterate over each of these years to create the animation. So pop data 1950, how about, equals pop data, this autocompletes are helpful. Okay. And then we could do top countries equals pop data 1950.n largest. It's a helpful pandas function. Do 10, and we want to sort it by population, but our column is specifically called tpopulation 1st Jan. We'll use that one. And just, I think, because we can see stuff a little bit easier with the Jupyter Notebook, I will do some of this code in there. Let's look at what our top countries look like. Okay, it looks like we're having issues. Okay, year is not right, it was time. Okay, cool. That makes sense. China, India, USA. That looks right. And now we want to plot it as a horizontal bar chart. So within matplotlib, we can do plot.bar_h. We want our Y to be the top country's location. That looks right. So we can start with this. Cool. So this is a good starting point. Maybe you want to order this the other way. So maybe we would actually sort this. And we would want to make it ascending. Is it ascending or descending? Ascending equals false. Let's see what this does. Ascending equals true, I guess, to organize it the other way. All right, cool. Good starting point. Copy this into our script. All right, so now that we have our bar chart plotted, let's actually animate it for the different years that we have. So to do that, we can import this very helpful matplotlib class. Import matplotlib.animation as animation. And just to be careful, I get sometimes nervous when our naming is the exact same. So we're going to rename this file to populationanimation.py, just to not run into any naming issues. Animation, there is a animation.function animation function that is important. Takes in a figure. So to get a figure, we should do fig axis equals plot.subplots. This defines how, the size of it. So I could do something like fig size equals, we want it to be pretty horizontal. So 12 by 6 is probably a good dimensionality. So I'll have 2 times the width as height. And now if we want to animate something, we can pass in this figure. It takes in a function. So we need to define now an animate function. You can call this function whatever you want, but we need to define an animate function for each of our frames. I think the easiest way to do this, I think this is ultimately going to take in a range. So we could try something like animate. The number of frames will be basically the frames will be basically, the unique population years. And we could just make this as like a sorted list. So we probably would want to make sure it's sorted. So I think it will be sorted by default, but just keep that in mind. I don't know if it needs to be, maybe it does unique return a list. Turns in ND array, that's probably fine. So our frames are the unique years. And the interval is the number of milliseconds to show at each frame. But now what we want to do within our animate function is basically, we will copy this data. So now our population data is just going to be this. So we can imagine each frame is each different year because we're passing in the unique years as our frames. Our top countries then will be the n largest of that specific frame. And then we can do our plot as we did before. And we'll add it to our axes. So little matplotlib kind of note is, using universal PLT versus defining axes. Probably easiest to do it this way. Doesn't matter super much on the logistics here. All right. And now let's see what we have. Let's see if this works. I will delete some of this extraneous code now. Run our code. Okay, we need to run plot.show here too. So this will create an animation. Just call it animation equals animation.functionAnimation. Nim, I could do a plot.show now. And this should animate it. And look at this. No, nothing happening. We got an error. Okay. It's not liking population data. Probably going to have to do a couple things here. I would say we probably should save this as like population data frame. Otherwise, it's going to cause some issues. And we also probably want to clear our access on each iteration so that other things aren't left on the screen. Let's run this. Yo, look at that. So there's some issues here. Some things are falling off the screen, but this is, a basic animation. So eventually India's overtaking China. But I feel like this as is isn't the most interesting, so let's add some more flair to it. Okay, so one thing that I recommend is that I don't love that the animate function is kind of like just working off of global variables. So one thing that I typically would recommend is encapsulating it in like a function. So we'll call this create animation. We'll pass in a data frame, and that will be good for now. We'll put all of this stuff in the create animation function, and then we'll call animation within this function, and we'll ultimately return our animation here. And so now this would be reading from our data frame. Okay, and so now to run this, we would do something like this, and we're going to have to call plot.show. We see it animating, but we now have it encapsulated in a function just to clean up things a little bit. Let's say you wanted to save this as a video. That's another good thing to know about. Well, these animations in Matplotlib have a save function. So you could save it as a GIF, but I think it's most helpful to save it as a video. So we'll call this like video.mp4. And then to save videos, you should use ffmpeg as it's suggesting. And you can also set like a frames per second. So let's say we set frames per second 30. Unfortunately, this would probably go too quickly because 30 frames per second would mean we'd be going over 30 years in just 1 second. But I'll run this just to show what it does, and then we will maybe fix this. So here's our video. And it goes pretty dang quick because it's covering 150 years. That would take 5 seconds. So again, this is the animation. But you could always change that to show like, 10 frames per second. And we also, another recommendation is artificially or non-artificially, just adding more granularity to the data so that each frame is a more slow progression, and I'll show that towards the end of the video. Okay, the next step now is to add some good styling. So I will create another function that I will say is just like, that I'll say is called setup plot style. That's going to take in the axis object, and we can do some different things here. Let's think what we might do. It's already giving me some suggestions. I love autocomplete. It's honestly probably pretty good. So this is saying basically hide some of the grid lines, set an X label, a title. So I like this information. And now we could call in each frame, we could do setup plot style on the axes. Let's see what this does. Here we go. For some reason, the titles are not showing. We're not sure why that is exactly. And oops, notice a small little issue here. We should add this setup plot style into our animate function and make sure that it's done on a per animation basis. Run this. And we see we get this. Got a title, X label. I kind of like, honestly, the left and bottom spines. So I'm going to remove these 2 lines, rerun this. Now it looks like this. We basically need to increase space on the left and right side of the screen. We also probably would want to put an actual count for each of these. So let's keep adding things. So another thing we probably want to do is add our year as text. So to do that, we could do add year text, or just add add year text, we'll call this. Pass in the axis, and we need to pass in the year, I guess, here too. And that we could add that to the screen by just doing the ax.text property. This specifies where on the graph it is. So if we wanted it on, let's say, the bottom right side of the screen, this is going to be the X position. So near the right side is going to be 0.9-ish, and near the bottom will be, I think it goes 0, 0 is top left, and 1, 1 is bottom right. So if we want it near the bottom right, 0.09, we could do something like this. Then we call add year text that way, run this again, and we're almost there, but it added it at the top instead of the bottom. So to get the bottom, we probably just need to switch this to like 0.1. Look at that. We could also specify what the bottom year looks like. And I will just say that, like, as you can see, a lot of the autocompletes, I have GitHub Copilot on. A lot of the autocompletes are coming from Copilot, and I think that this is a really recommended strategy when you're using Matplotlib, because there's so many little different controls with Matplotlib, so hard to keep track of them all. So using AI tools to your advantage to help you kind of autocomplete things and then tweak as needed is very advantageous. Right now, our data is in thousands of people. I might recommend making it in millions. So to do that, we could just basically update this function that we used originally and just do clean df t populate. We'll just call it population is equal to this data, and we'll divide it by 1,000. So right now it's in thousands. So if we did this, it will be in millions. So this population is in millions. And we could even drop these 2 columns if we wanted to simplify things. So I'll save this as a new total population, 1 Jan. And we'll make one equivalent for the July, just so we don't get confused if we do end up using that.
June.
we see our new animation. And to clean this, I might add in millions up here, and I might just call this total population. I don't care if it's 1st of January. All right, we're getting there, we're getting there. Starting to look better and better. We still need to fix this x-axis. How could we do that? Once we get to this point, I kind of recommend, honestly, leveraging like a ChatGPT to help you fix some things. So like we are seeing that our x-axis or our y labels are getting, they're falling off the screen. So I might just ask that in ChatGPT or something like, I have this code, but my y-axis labels are getting cut off. How do I fix? Okay, so calling plot.tightLayout will help here. Plot.tightLayout on each animation. This will help us fix our frames. Look at that. So this is looking pretty good. I'm trying to think of other things that we might want to do. It's really just a matter of styling at this point. Adding our flag images potentially. So like if we wanted our population to show, so like maybe we wanted the actual numbers to show and we wanted them to be formatted with commas, we can do, let's think, x.text. We want it right next to the row of text. So we could iterate, we can do some creative stuff here. We can iterate over each of our rows. So for index I row in top countries dot iter rows, we could add the population to that. That looks good. So let's see what this does. Okay, so this code gives us a number next to each of these rows, but to format this maybe a more interesting way, we could, instead of doing this string int, we could use an f-string syntax. So f-string, surround this, and we won't use an int. We will use this bracket syntax. And then you can use this colon syntax, and then we want commas to show up. And we also want to use 2 decimal places. So by using this syntax, the commas, so if you have, let's say, 1,000 or greater, it's going to use a comma to split, the 1,000, and that's at least how we do it in the United States. I know that sometimes the periods and the commas are reversed. And then it will use 2 decimal places, and we want to close this f-string out. Let's run this again. Now we see we get something like this. So watch what happens when we get to over 1,000. We see now a comma. So it's just a little bit nicer of a formatting. Another thing that you might want to do is add a little bit more granularity to your data. So in the final code that's in the GitHub repo in a file called barchart.py, one way that it makes use of this granularity is that we took the data, the UN country data, and we basically realized that it had populations for January as well as populations for July in a single year. And what we could do is basically, instead of doing years by themselves, we could use a year with a given month, and then the January month and the July month. And then we could fill in all of the different months, kind of interpolate the data for 1, 2, 3, 4, 5, 6, all the way up to 12. We can interpolate the data between the points that we do have. So we're basically, adding a month via this code here. And then what we are doing is going ahead and adding blank rows for all the months that we don't have. And then we get something that looks kind of like this, where we have month 1 and month 7, but we don't have these months in between. So we can call a function called interpolate, which is a pandas built in, that will fill in that data for us. And then when we actually run our animation, we can go ahead and have more granularity because each frame is now a year and a month. So in the final code, it's using this timestamp column that's a year and a month. And then each frame is showing that. So you're seeing the data progress a little bit, not so jumpy. It's a little bit more of a seamless transition. And that gives you something that looks more like this. In that code, we also leverage these flag images using also the PIL image library. And we basically load all of the flag images in. And this code is all linked in the description. So we see we load the flag images using this load flag images function. They're all saved in a dictionary. And then for each animation frame, we add them to our axes and basically leverage them in the animation. Some of these specific details, so things like this, which is helping formatting some of our numbers, some of this might not make like perfect sense, but that's why you use like what I like to do with Matplotlib, because there's so many different parameters, is that I can use a large language model to help me put things together, and then I can look through the code and understand enough where certain things are happening to make additional tweaks as I need. So it's basically like, you want to know the basics to get you, 50% or 90% of the way there. Use the LLM to get you to like that 100% or 99% way there, and then use your own manual examination of the code to then help you become 100% there. Absolute final code is in barchart.py, linked in the description. This was creating a bar chart race in Python with Matplotlib. If you enjoyed this video, make sure to throw it a thumbs up. Subscribe to the channel if you haven't already. Let me know any recommendations you have for future videos. Until next time, everyone, peace out.